those that are watching us online, I'm pulling up problems on the board. I'm going to pull problems up a little bit at a time and then talk about them. So you can stay in live time and actually attempt the problems, or fast forward to us talking about them, whichever way you want to do it. So right now, all I want you doing is part A, and then part B, you're finding mu of x bar, sigma of x bar. Thank you. All right, so problem A, really the only thing that matters is a random sample of 15 fish having a mean length greater than 10 inches, a random sample of 50 having a mean length greater than 10 inches. First part, what is the correct, so it wants to know which one is more likely, getting something that far away in the first situation or getting something that far away in the second situation. Which one is more likely? The sample of 15. So that's the first part of answering this question correctly. The second part is the justification. I'm hoping more people this year would get it right than in a normal year, because I've stressed this point a lot. The way you choose to write it might be different, but what idea is that leads you to the answer? The bigger the sample size, the less variance. So the first one is more likely to vary that far away versus the second one. They talked about sample answers. Like if you ever did a problem like this and you wanted to like make up what a sigma was and then plug it in as that number divided by square root 15 and then that number divided by square root 50, you could technically do that. Say that again.
If the sample is bigger, it has more variance or less?
Less variance. The bigger sample varies less. So bigger sample is going to vary less. So it's more likely to make it that far away with a smaller sample than it is with a bigger sample. All right, now part B is a very, very straightforward problem that I that they are trying to make it so easy on you that they make it hard. Like this should be such an easy answer that a lot of you are going to miss it. Hopefully you don't miss mu of x bar. Mu of x bar equals mu, which equals what? What is sigma of x bar? That's your answer. And that's why some people get confused here because they think they have to do sigma over square root n, but it very clearly here said the sampling distribution, the standard deviation of the sampling distribution of the sample mean. Well, that's why symbols are so important. Standard deviation of the sampling distribution of sample mean, that's this, is 0.3, so it gives you that number.
Does it count off if we didn't say sampling distribution?
Yeah. Yes. But less than most other things.
And I just said standard deviation of sample
Of what?
mean. Of sample mean.
Yeah, I would just do part. Like, I mean,
Okay.
I don't know how my points are gonna be, but yes, something, but not much. All right, so do you see why that one is? It gives you sigma of x bar and not sigma. All right, so I'm not gonna go through that whole problem, but that was the point that I wanted to make with that one. Actually, I do want to talk about part C. Suppose the standard deviation, you don't have to write this one. I'm just going to talk through this one. Suppose the standard deviation of fish lengths in this lake was non-normal, because this problem actually did tell us normal. I didn't actually answer it, part B. Would it still be appropriate to use the normal distribution to compute the probability in part B? So this problem actually told us the population distribution was normal. So B or C says, suppose the fish length was not normal, would it still be appropriate to use the normal distribution? Yes or no? Yes. Why? The central limit theorem. So I drew this for another class and I was explaining something, but our population distribution is either normal or not normal. If it is normal, we go straight there. We can use the normal approximation. This one is not normal. So because it's not normal, I would have to see what our sample size was. Our sample size was big enough to use a normal approximation because of central limit theorem. So just because we didn't go through route 1 to say we could use normal approximation, we went through route 2 and that's fine. I think I'm going to do this one in pieces. So I'm not scrolling up all the way, which is kind of tough. Well, no, I'll just do this. I am telling you right now that this is not from this chapter. A tire manufacturer designed a new tread pattern for its all-weather tires. Repeated tests were conducted on cars of approximately the same weight, traveling at 60 miles per hour. The test showed that the new tread pattern enables cars to stop completely in an average distance of 125 feet with a standard deviation of 6.5 feet, and that the stopping distances are approximately normally distributed. What is the 70th percentile of the distribution of stopping distances? I want you to answer that. I'm telling you that's not this chapter.
to get books and throw it in. I'll be back.
What is necessary to solve this problem? And I'm leaving that as a very open question so that your responses might be different. What do you need in order to solve that problem? Whether you physically need it or the problem tells you, like what kind of thing, what did you need? Think about percentiles. When do we use percentiles? Area and z-score stuff. So think about drawing that. What does it mean to be percentile? How do I draw a percentile? Shade it from the left up to that. So 70%, is that more than half or less than half? More than half, so my line should be where? On the right side, so oh, I can shade more than half to the left. And this right here is 70%. So how do I now find my answer? What do I do now that I have this? So you're looking in, whether you have your z table or not, like, so you're looking in here for the closest thing to 0.7000. And somebody who has a z table, what's the closest z-score to that? 0.52. Now, the problem didn't ask you for a z-score. It asked for what's the, what? All right, so it didn't say very specific. Okay, so my z equals equation is this. Do I know my z? Yes, that's 0.52. Do I know my x? No, that's what I'm solving for. Do I know my mu? Which is what? Do I know my sigma? I don't remember what it is. 6.5. Algebra. So multiply both sides by 6.5. Then add 125. I just did this. Is it 129.55? I can't remember what the time. What? 128 point what? And technically my units would be what? The feet, is that what it is? All right, so that's chapters ago. Now, part B is tricky for quite a few reasons. I want you to read part B, and what I'm going over are actual free response questions on the AP exam, like past questions. I want you to read B and write down as much as you can and get as far as you can, and then we're going to start talking. So what is the probability that at least 2 cars out of 5 randomly selected cars in the study will stop in a distance that is greater than the distance calculated in part A? So like you should always do, just start writing down things that you know. And honestly, I am very surprised that this question was one on the AP exam. I think this one's tricky for reasons that aren't things that I would want to test if I were testing things. All right, so 2 out of 5. If I'm starting to write things down, what is 5? Your sample size. So n equals 5. So I want the probability of what? How can I write that? How can I write the probability of at least 2? Does anybody know what kind of problem this is? Or think they know what kind of problem this is? It's a binomial. And that part I get with why they wanted to do this one, but that's not even the tricky part. Like, I like the fact that it's a binomial. I like the fact that it's a binomial mixed in here. But there's a third part that I think makes it tricky. What do you need in order to find stuff with binomial? I've got n. What else do I need? Now this one says, what am I defining as success generally? Oh yeah, 120. And this is the part where I think this part is really tricky for a reason that shouldn't be. He actually said that one very, very well to make it easier than most people would try to make this one. What is it? How do I figure out the probability that they stop greater than 128.38 feet? This is the easiest answer on the entire question. So what's the probability that it took them longer than 128.38 feet to stop? What's this? And that's why I don't like this problem, because that's the easiest problem on the whole problem, or the easiest part of the whole problem, and they make it trickier than they should. So now that you know that, I feel sure that you can solve this problem. But I kind of want to touch another point here that this happens a lot. So let's say you're on this question on the AP exam, and you get to this point, and I get that it's a binomial, and I have no freaking clue how to find a probability from part A. So that's all I could do, right? So in that situation, you're on the AP exam, you literally have given up on guessing what that probability is. What should you do? Pick a wrong answer to go here and keep going. Because I'm going to get credit for everything except picking the right peak. Whereas if I stop here, I now don't get credit for the rest of this problem. And I'm bringing this up because on chapter 6 test, there was a problem where people got really confused with when I said draw a probability histogram or probability distribution chart for something. And people got totally thrown off by it, which I get. So I only counted that part for 2 points. But then it said, now draw the graph of it. Now tell me the shape of that graph. And some of you just like stopped because you didn't know where to start, so you didn't get credit. Whereas I had some people that basically just came up with something, drew a graph of it, and told me the shape of that graph, and I still gave them all the credit for that. So this happens a lot in our class. If you get stuck on something and you need it to do something else, and you're at a loss and you know you can't figure it out, make it up and then keep going with it. Because I'll only count off for it wrong once. So now technically at this point, this will be point 3. I could continue this problem. I'm not going to waste time to do it, but we just plug it in for binomial. Now, I'm actually going to come back to C. No, maybe not. So then what does it actually want you to do in part C? What is probability that a randomly selected sample of 5 cars in the study will have a mean stopping distance of at least 130 feet? What does it want you to do there? So this is this chapter 4-step process. And so on the AP exam, that's 3 completely different things mixed in together into one problem. So I'm more concerned with you seeing that things are going to be mixed in together than I am with you. Oh, and this is another that threw people off a lot. If I were writing out the 4-step process, I can't remember which problem we started with. What would I write as my population here? So let's go backwards to figure this out. I mean, if I define mu, let mu equal what? In words, let mu equal the mean. This part should be easy. I didn't hear what it said. In words. Stopping distance. So what are we calculating the stopping distance for? On what? The tires aren't stopping. What's stopping? The cars. So all the cars of the same weight at 60 miles per hour would actually be your population.
So
That's so you now connecting chapters because we can actually do that now that we have enough material. If you were thinking about it that way, think about it now from a chapter 4 perspective. What is our explanatory variable? What's our response variable? Stopping distance. What is our treatment? Let's call it that way. Or what are we imposing? What are we doing to it? That's a weird way to ask that. I don't want to answer it that way. The explanatory way, yeah, I don't want to ask that way. All right, this one I think is another very extremely tough problem for reasons that I don't love. A local radio station plays 40 rock and roll songs during each 4-hour show. The program director at the station needs to know the total amount of airtime for the 40 songs. Okay, so as I'm writing this, because we're actually going to do this one, as I'm reading this, I want you to write down anything that you think is necessary. So like if you were writing it on paper, things you would circle. The local radio station plays 40 rock and roll songs during each 4-hour show. The program director at the station needs to know the total amount of airtime for the 40 songs so that time can also be programmed during the show for news and advertisements. The distribution of the lengths of rock and roll songs in minutes is roughly symmetric with a mean of 3.9 minutes, standard deviation of 1.1 minutes. So just looking at that and thinking about things that I would have written down if I had it in front of me and are marking on it. All right, so what's something I would have marked down? Say it again. Which is what symbol? Because it's the whole distribution. So this is our what? What else? One other thing. Which is So those are things you should be able to pick out as we read it. This is where I think this problem goes a little bit confusing. So I'm going to talk through this part. I wouldn't like this problem because I feel like it tests something outside of what I would want to test. The program director at the station needs to know the total amount of airtime for the 40 songs. So I've got 40. I need to know total amount. But all of these are in terms of what? Mean length, this length. This, so this is talking about number of songs. This is talking about total. Well, what can I find with the total and the number? I can take the total and do what with it? And what does that give me? This is very, very basic statistics. If I take the total and divide by n, what do I get? The average. Right? So this next part of the problem says if the program manager schedules 80 minutes of news and advertisements for the 4-hour, 240-minute show, only 160 minutes are available for music. Approximately, what is the probability that the total amount of time needed to play the 40 randomly selected rock and roll songs exceeds the available airtime? This is the part that I don't like about it. Is the 80 minutes necessary? No, because all it did was did 240 minus 80 to get us the 160, so it did that on purpose. But I'm not actually, I don't need the 160 by itself. What do I want to do with that 160? So this is the length of a song. This is the standard deviation for the length of a song. But now all of a sudden I've got this total time. So I divide it by n to make it an average instead. So I actually do so that's our X bar that we're comparing. And I think that is a lot of easy math that's really confusing in wording, so they're testing, in my opinion, the wrong thing here.
That answers the question.
That's to start the question.
Perfect.
So I'm telling you, I think it was tricky to hear. Now I want to work on this problem. So now I actually want to use this one to find. So approximately, what is the probability that the total amount of time needed to play the 40 randomly selected rock and roll exceeds the available airtime? So that would mean our mean is what? Because of this word, we're finding the probability that our X bar is what? Because of this. So if it's greater than 4, we went over that 160 minutes. And that's where I think people get really tripped up getting to that point to start the problem. And I think that's a lot of side stuff. So this is what I want you to actually start with right now. You're going to end up finishing it for homework, but I want you to go ahead and write state. And then I want to kind of talk through that. Yeah, it doesn't matter. And I think some of you are going to get a little bit confused with at the very beginning of this. That's why I'm just on this part. So what actually is our population here? And I do expect probably about half people to do this part wrong, slightly. What is our population? What do you think our population is? Because if you're wrong, you're probably just going to say, the way the problem's written, it's really all what kind of songs? All rock and roll songs, or all rock and roll songs that could have been played on the radio. So what is our sample then? The 40 randomly selected rock and roll songs. And I think some of you would have started to write your population as your sample, like would have thought your population was the 40 ones that were selected for the show. But which ones could have been selected for the show? Technically all rock and roll songs. The sample is the ones that actually were selected. So what is defining mu? This part should not be hard. Remember, we've already written out our population in detail, so defining our mu should not be difficult. The mean length of the rock and roll songs. Yeah. So let mu equal mean length of rock and roll songs. And then the only other part we have to do is what we're finding the probability of, and we already wrote that, or I already wrote that up there. So it's finding the probability that X bar is greater than 4. And then go ahead and write out plan. I'll give you a couple minutes to do that, and then we'll talk about that one and then finish the rest of this for homework and something else. Like I said, I did do a video of me in detail going through number 3, like actually writing all that out for the homework last night. But my last class didn't get to go through these problems like we just did. I have everything pulled up that you need. I think it said like symmetric, but it didn't say normal. Yeah, it just said roughly symmetric. What's the first thing we check in plan? 10% condition. So capital N is greater than or equal to 10 times lowercase n. What is our lowercase n? 40, which gives us 400. So capital N is greater than or equal to 400. So we would write there are at least 400 rock and roll songs. So 10% condition is good. What do we write out for normal? What? No, so this is with means. So means is a little bit different. I'm using n. My n is 40. What do I need to say about my n?
Greater than.
And so what tells me that's okay? So that's the only part that I had to do like mathematically to say this is why it works. But this works, which means what? We can use normal approximation. And I haven't, we've talked about that, but I haven't like written one out with you that way, so I want to make sure that we covered it. Say that again? That's always 30.
What?
That one's always 30. So when I'm checking, yeah.
So are we just doing?
Yeah, so I'm gonna give another problem too that you'll do a 4-step for, but one of them is gonna be finishing this one, and then I'll give you the other one to do. So we've already done half of this. Yes.